Hello. In this video, we're going to do a deep dive into my Arduino code. Now, I have lost track of the number of takes I've done for this video. First, the stutter is up on high, um, and doing a video on code is kind of boring, um, and I tend to just ramble on. So, I'm going to try to make this interesting. I'm not going to do any animations or presentation like stuff. That's all just too much work. So, I'm going to go through the code, and hopefully, you get something out of it. Now, the Arduino is the device I'm using to control a lot of the lights and motors inside of the Lego town. Now, the Arduino is a simple microcontroller. That means you can think of it as a computer that runs one program, and that's it. You turn it on, launches the program, and the program stops when it either crashes or you turn the device off. Um, so, Arduino is a very good device for this kind of problem, as in it has one thing to do or a couple related things to do. It's simple. You don't have to deal with, operating system upgrades or too many things going on at once. That they are a very good single purpose device. I am still learning how to write Arduino code well. Every development platform, whether it be Windows, Android, iOS, whatever, uh, the designers of that platform tend to have patterns that they would like you to follow when you're writing code. And I have an old mantra that says, don't fight the framework. And another way of saying it is when in Rome, right? And so that's what I'm trying to do. A lot of the example code for that I've seen for the Arduino is a lot of just random lines of code that just so happen to work. And so I'm trying to structure this code in a way that is maintainable and extendable. Now, it is still very C language centric. And soon I'm going to refactor it to be to use the C++ language constructs to create even better code. But I'm still figuring out what my entities are. So we're keeping it simple right now. So let's get into the code. The first file is what I call my configuration file. It has some pound defines that kind of define my hardware configuration. I'm using the pound define language construct to help guarantee that what I don't need is not in the program, because the Arduino has very limited resources and you don't want to waste any space, even on some unused variable. So the pound define is a very good way to tackle that problem. So if you just look at the file, we have the first two lines help define the low energy Bluetooth identification. So every device that uses low energy Bluetooth has a unique identifier. This is almost like a UPC symbol for a product that you buy. It uniquely identifies the type of device, not the device itself, but the type of device. And then we give it a name. So in my system, City Streets type of device has that ID and that name. And then I define some of the other properties. We're using the Arduino matrix. That is, it has a light matrix embedded right on the board. It's pretty cool. We have a motor. It's plugged into pin number 9. We have lighting. I use ports 3 and 0 for my lighting output. And the true and false is whether it's dimmable or just straight on and off. And I also have a lighting sensor port as well, so I can detect ambient lighting to automatically turn lights on and off. Okay, so let's now move to the actual implementation. This file currently has 387 lines of code. I will be eventually breaking it up into several files when I do the C++ refactoring. So if we scroll all the way back up to the top, the first thing I do is I define the structure for my lights. Now you saw that data in the config. We have the pin number and whether it's dimmable. Then the next piece is another macro called btchar. And what this does is it takes that service identifier and prepends it with another string. So every property that's on your low energy Bluetooth device has its own ID as well. So like motor power, or you know, the value for how intense the ambient light needs to be to turn the lights on or off. All of those need their own unique identifier as well. So I just have this convenient macro here to create those identifiers. These are the pound includes, and these are all wrapped in the pound if defines as well, because some of these may declare global variables that I don't want even in the program if I'm not using the device. Now, every Arduino program, let's make this window bigger. Every Arduino program has a function called setup, which gets called once, right when your program is launched. And this is where you do hardware setup. So we do our system setup, we set up the matrix, we set up our motor, we set up our lighting, and we set up the low energy Bluetooth service itself. We'll talk about the schedule runner in a moment. And then this is the core object, as it were, for low energy Bluetooth. So, and you give it your service identifier. Now, every Arduino program then has a function called loop, and what the very, very minimal operating system does on the Arduino is it just, on your one program, after call setup, it just calls this function over and over and over and over and over again. And this is where you perform your operations. Now, since I want to perform several operations, I want to, respond to live events from the client saying turn the motor on. I want to read my sensors. So there's a couple of things I want to go on at once. So I use what they call the task scheduler. And this does what they call cooperative multitasking, which is you say, okay, you know what? I want this task to run once a second, or I want this task to run 10 times a second. And it will then call those task functions on the best it could for timing. They're never called concurrently, not at once, but serially. So one after the other. So this is kind of the simplest way to have your Arduino perform multiple tasks that appear to be concurrent. Now let's get into the business logic. So first I have system setup, which all I do is open up the serial port for logging, really. I don't do any other serial communications over the serial port. And then what I'll eventually do is turn this off, because when the Arduino is running my Lego town, I'm not going to be staring at the logs. Then we have the Arduino LED matrix. So this is a third-party library, and I create the matrix. Now, for the property in my program for the client to transmit a new picture that wants to display on the matrix, I create this characteristic. So I'm kind of describing the property. That's its ID. The client can read it, it can write to it, and if there's a change to it that it did not invoke, it will get notified of those changes. And then you have to give how much memory that property needs. So I have a matrix setup function. I call it the begin function that I need to do. Um, then I have kind of my test pattern to know that, hey, the machine's running. Yay. It shows a heart. Um, and then for the property, I then need to register the property itself with the low energy Bluetooth service. So I first up here, I declared the property. I give it its initial value, and this is where if the client sends us a new picture to send, that's the function to call. And then I add the property to the Bluetooth service. So if a new value comes in from the outside, we read it, and then we set the matrix just like we did inside of setup. Yeah, where's that? Oh, right there. Oh, go away. Right there. Okay. So there is a pattern here that I'm starting to kind of formulate, which is, so we will have a C++ matrix class. It will have these as members. It will have these as functions, and these will sit in another file called, matrix.h, matrix.cpp, and that will kind of reduce the clutter in this file and create something more maintainable. The motor is very similar. We have our pound defined to see, do we even have a motor? Do we have a pin to hook up the actual hardware to? And this is the third-party library that manages that hardware. This is all of the variables that we need for our business logic to maintain power on that motor. These are the characteristics or the properties. We have motor control. We have feedback, and we have calibration. And what these do is, this is what the client says, hey, they say set power to 11. We can't go up to 11, so we give the feedback saying, nope, we're only at 10. And then a lot of motors don't like low voltage. They don't have a transmission like your car, and so they really struggle with that, with little power. And so I have a threshold that says, okay, given this motor and his load, physical load, it won't actually start moving until we hit, power 3 or something. And so you can kind of calibrate that value where we don't even try to make the motor go until we hit a certain power. And so we have our setup function, which, once again, third party manages that pin now. We set up all of our properties. We respond to the properties being set. And then this is our business logic. It's the logic I was just talking about like the calibration threshold and so forth. And then down here is where we, tell the client, hey, this is the value that you that was actually set. And then if there's a change, we actually tell the motor, write the value. Now, a little thing about servo motors that I've learned is that it's hard to get back to 0. If you call this function, it stops. Great. So I have this condition in here. Now, what's going to happen is when I move to C++, I will have a polymorphic class to handle the hardware, because not every motor is going to be the same type of servo. I may have some Lego motors in there. I may have whatever, just different types of motors. But all of this logic stays the same. The only thing that changes is this. So my motor class will just have a polymorphic method of write power. And then this will change depending on the type of motor that I have. Now, if I don't have a motor attached and somehow this function gets called, I'll at least log that, you know, someone asked for the motor. Now, lighting, almost the same identical pattern. We have our conditions on if we have lighting. We have our internal state to manage the business logic. We set up our characteristics, but this time we do include a read-only characteristic for our sensor. And it turns out if we don't have a sensor, the client can write the value for the sensor. That will allow me to have like one ambient sensor across the entire system. And if I need to tell one Arduino that sensor reading from another, I can do that. And then we go down. This handles setting the pin mode for all of my lights. I register all my characteristics just like you've seen before. And here is where we register run our task. So this is our first case of a sensor. And so we want to read that sensor on a timely basis. Now we're only reading it once a second because it's ambient light and we're turning lights and off. We don't need it to be fast. So once a second, we ask it, hey, could you read the sensor, which is our lighting task, and call its function. And so if we look at lighting senses, and here's where we read the sensor value, we perform our business logic. We tell the client, hey, this is the value that we sensed. And then we perform even more of our business logic down here, which will turn the lights on and off depending on the calibration and the sensor value. And we keep going down, and once again, the same kind of pattern. Okay, if someone calls this function and we have no lights attached, at least log it. Last bit of code is managing the low energy Bluetooth advertisements. So once again, we create a task, and this time we're doing it 10 times every second. So these are microseconds. So 1,000 of these is 1 second. We want to be very responsive to client requests like changing power, so forth. This is what it takes to set up the Bluetooth library. We call begin. We give it the advertised name. So when the device is browsing the local area for Bluetooth devices, that's the name it's going to see. We have 2 event handlers for connected and disconnected. All we do is log in them. I'll eventually turn that off because it won't be necessary. And then we actually say, okay, let's advertise. Let's tell the world that we're out there. And then we add our task, which is Bluetooth low energy pull, which basically just asks the library, say, got anything for me? Got anything for me? Got anything for me? That's it for the code as it stands today. I'm actually kind of looking forward to doing the C++ refactoring. It's going to clean up a lot more of the code, but you can kind of see how I've got it modularized. I'm going to put the link to this code in the description for this video. So if there's anything in here that you think you would find useful, please copy and paste away. And that concludes my first coding video. Thank you.